Welcome to Pantechelearning. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel. So next we can move on to the Poisson Noise. So Poisson Noise, the implementation whichever we are providing, it will be in a high level manner while compared to the Gaussian noise. This doesn't have any of the additional parameter to point out over there. So we can directly implement it. The syntax is IM noise where within quotes Poisson. So Poisson is the keyword and therefore everyone can see by comparing these two images. So this is completely clear and here we have some range of noise and this noise value cannot be changed at any cost. Now let us apply the same section for grayscale image. Okay, so here we can see some slight differences while compared to the color regions. So these are known as the noise parts. So here there is no such kind of differentiation. Here we can see. So this is the method of implementation in Poisson noise. The very simplest noise which we can work on it. Next we are going to see salt and pepper noise. This is the most available noises while compared to everything. For example, if you take any of the CT scans, MRI scans or any other images, the most occurred noises are known as salt and pepper noise. And this is also very easy to apply. So here IM noise, the particular image which we have to provide input, then the salt and pepper. So this particular is known as the keyword and therefore this is the ratio of the noise. So here we have to apply only the single ratio for the total image and therefore the noise gets applied over here. So let us start from point 1, then only the variation we will be able to understand. Okay, so for salt and pepper noise, this is the minimum level. While compared to Gaussian, it is a little bit less, but this is little bit powerful and for this only we will be applying most of the median filters. Now let us vary the value. I'm just varying only slightly for 0.4. So based on that point itself, you guys will come to know how that variation is being applied. Now the same thing, let us try it for the grayscale images. So on point 1, this will be the respective output for it. Now the same thing, if I change for point 4, the same value, this will be the noise applied. Rather than applying it for a color image, we will be able to see a major difference inside the grayscale images. Like in previous images, we will be able to just check this kind of sections and all. And this is mostly applied for CT scans or MRI scans, like that kind of devices only, because whatever the device the noise is being generated means inside the scanning part or that particular module which is known as image sensor, those image sensor is connected with the help of an antenna which generates a frequency of band. So that particular bandwidth or the frequency, whenever it is generating the resonance, definitely some of the unwanted signals will be there, and from that only they are able to obtain this kind of different scan images. That's why whenever we are applying for biomedical kinds of sections, especially neural networks, we will do this image processing by removing the noise, and from that noise removal only they will be able to extract the features. Definitely there will be a particular variation while compared to the noise based feature and noise without noise feature. Okay. For this kind of doubt, it is nothing but RGB. It is a kind of color variations. So this combined colors will be reducing that particular white or black spots inside that particular image. Normally it is like throwing out salt inside an image only on any of the objects. So if you are throwing the salt on a color object, you guys won't be able to see that salt as high as possible. If you are sawing it, throwing it to a black and white or pure black means, then you may know that particular difference. So the same thing only over here. Inside the RGB, the white and all, it is very difficult to find out the white spots. Same thing if you go for a gray image means it is very easy to spot out that area. Okay. So next we can move on towards speckle noise. Now we are going to see the speckle noise. This is also similar to the salt and pepper noise only. The same mode of implementation. So now I have added that particular speckle noise into the color image. So while compared to the salt and pepper noise, it is not able to see inside a color that much highlighted one. But here the brightness of that particular image also gets reduced, and at the same time the noise similar to the salt and pepper also will be added. So when that brightness is reduced, this particular noise will be highlighted over here. So that is one of the major difference between the speckle noise as well as salt and pepper. Now the same noise, if we apply it in a gray image, means so this will be the type of noise. So here it is not like throwing a particular salt on it. There you will be having the white spores. Here it is completely with the black pores. So that is that a complete difference we will be able to analyze whenever we are comparing the RGB and the grayscale images with multiple section of noise. So now this particular variations also can be done. Let us check for point 1 because now we have seen for highest variation. So for point 1 also it is almost in a high oriented range only. Okay, so these are the different noises available over here. Now let me display all the noise. So first let us go over Gaussian, Poisson, salt and pepper, and speckle. So let us provide a bigger display for everyone so that we can see all the outputs in a single view. So speckle noise. I hope this is salt and pepper, Gaussian. Okay, so these are the different noises available inside an image processing. So noise removal are also known as the filters, which remove the unwanted parts, and we will be able to smoothen that particular process inside the image. Because definitely if any of the images are affected with the help of noise, it is not possible to remove that particular and reconstruct that particular image through the image processing technique. So for that only here we can say it as noise removal, and this is one part of smoothing that particular images. The smoothing process mostly will take effect only in grayscale images, and it cannot be mostly applied for the RGB based image. The reason is smoothen the grayscale images means it is very easy to smooth because it has only two sections of combination. Whereas if we go for RGB means there are multiple sections like RGB, and if you just combine each and every color means some more sections also will be introduced. So therefore it will be little bit complicated while compared to the grayscale image. Now here first we are going to see the filter for a Gaussian based section, which is known as Gaussian filter. So now here I have an image known as, okay, so here that image is not there. Anyway, I will create a Gaussian image over here. Yeah, that's sure. So here I am creating a Gaussian noise. Yeah, so therefore the image has been created. So here is that particular image, and here I am going to read that particular image. Okay, so the noise was not properly applied. Point 1 with point 1. Yeah, so now the image has been created. Now let us see that particular filter. Oh, again I am running the same thing. So while comparing to that right and left image, so you can see only some variations that has been applied over here. So this is nothing but the Gaussian filter. The Gaussian filter, it is commonly known as the Gaussian blur. So by using that blurring technique only, everyone will be changing their particular kinds of noises into a denoising section. Blurring and deblurring is completely different. Noising and denoising. The denoising mostly it is applied based on the blur sections only. So this is just an implementation of Gaussian filter and Gaussian blur. So next we can see how to apply it for salt and pepper noise by using the median section. So for median, here we have created the same thing only and commenting the rest of the parts. So this is the part of salt and pepper. I am sure. Then bracket of. Okay. So here I have to read the noise image. Now let us see how the changes applied for. Yeah. So now you can see how much that particular ratio of noises has been reduced. So this is nothing but known as the median filter, which is applied for salt and pepper noise. Okay. So for the point 1 variation, point 1 applied noise means we can get a clear image. So on which point we are losing our section means I hope it may be from point 3. Yeah. So from point 3 only we will be losing that particular kinds of clarity. But anyway, it will reconstruct as maximum as possible. Now let us try the same for color image. So here for color image, it is not accepted. The reason is it should be always the 2 dimension, because when we go for the grayscale, only the dimensions between 0 to 258 is applied. The same thing if you are going for an color means RGB, 0 to 255, 0 to 255, 0 to 255. So this will be that particular variation, and therefore we will be occurring an error over here. Okay, now let us get back to the gray and let us try the same median filter with other filters. For that, we are taking this line alone, and let us start with the Gaussian itself. Even though we have seen the Gaussian blur, so here I have to add it as G noise. Okay, so here we no need. Yeah, so everything is same. Okay, I did not add that IM noise, IM show. So for Gaussian noise also it is not applicable. The reason, here we have two different parameters. Okay, now let us go to the Poisson noise, because almost the Poisson as well as speckle, everything is same over here. Okay, inside IM show here I have made one mistake. Sorry, actually it will take that value. Yeah, see that particular dimensions, it is not acceptable for this median filter. Even though here we have given the 0.1 is to 0.1, it is not acceptable. Now we are going back to Poisson. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel.